when I want to find the x-intercept, I set y equals 0, right? Because that's when you have no height. Right? When the height is collapsed down to 0. If you want to find the y-intercept, you set x equals 0. So it's kind of flip-flop around, right? Problem C, we want to use the x-intercept and the graph to solve the inequality. I want to know what interval that my graph is positive and what interval is my graph is negative. So if you look at there, what interval my graph is positive? Positive right here, right? That one and that one, the two lines right there, the graph is stay above the x-axis. So if you look at the interval from negative infinity up to negative 17/3, that's when it's positive, right? Let me write that down. So here, f of x is positive. I see from negative infinity, for there, from negative infinity to negative 17/3. Always you parentheses when you're talking about positive, negative interval, or increasing, decreasing. Where else? Union, and then it skipped, and then from negative 17/3, and then negative 7/3. That's when it's below the x-axis, right? So that is negative. Yeah, let me highlight the negative in blue. So that's when it's negative. And then it's positive again from negative 7/3 to infinity. You agree? So f of x is below the x-axis from negative 17/3 to negative 7/3. Let me rewrite my number 3. Yes. Yeah. Yeah. All right. Do you have any question for part C? Part D. Find the decreasing interval of the function y equal absolute value of f of x. Now it's no longer f of x. It is, I just want the positive part only. Do you guys remember how to graph the absolute value of any arbitrary function? Well, step number 1 first, right here, let me go back up here. I think I wrote down here. Right here. If I want to graph, if I want to graph any arbitrary function, absolute value of any arbitrary function, first I'm going to graph the regular graph first, right? Any portion that above the x-axis, I leave it alone. The one that below the x-axis, you flip it over, right? Mirror image. So same thing here. So the red part is above the x-axis, so I'm okay with it. But for the blue part, it was underneath, so I kind of flip it over the x-axis. -5, so +5 here. Like that. Like that, right? Like that. All right, okay, you guys should be able to tell me the increasing, decreasing interval now. It's decreasing from where? Let's do decreasing first. Decreasing. Someone tell me where is it decreasing? Let me move that away. There. Decreasing from negative infinity to, yeah, negative 17/3. Union where else? It looks like from -4, right? From -4 to negative 7/3. Everybody see that? Right there, -4. So at -4, yeah. Maybe I'll use my hand. So it's decreasing right there. It's decreasing. When it decreasing, you want to project to the x-axis. You want interval, right? You don't want the y value. Y value, that's range. So decreasing from negative infinity up to negative 17/3, and then it increasing again but then it start decreasing from -4 to -7/3, and that's it. That's it. And then it's, let's see, increasing is from -17/3 up to -4. Union from -7/3 to infinity. You should be able to know how to do this. We'll be on the exam. Well, not this problem, but the increase and decrease in interval. Right. Yeah, we done that part. I'll post that after class. Okay, let me recap. So far we did linear equation, we did absolute value equation, now quadratic. Right, now quadratic. Quadratic function is a function of the form f of x equal ax squared plus bx plus c where a, b, c are real number. A cannot be 0. If a be 0, it's not going to be quadratic anymore, is it? The graph is the quadratic function of a parabola. Now, there are two ways of writing the quadratic function. One way is the one I highlight in red, is called general form. General form. And the other form is called vertex form. And you see why. Where's the vertex? The vertex is HK right there, right? What's your vertex? HK. That's what I see. From that form, you can tell me what is the vertex right away. Hence vertex form. Now, if I give you the general form and I ask you, can you calculate the vertex for me? Then you would use this formula. That formula. Right? The x coordinate h. Sometimes I call it the x coordinate because that's the h. It's kind of correspond to x, right? Is -b/2a. And once you have h, you want to find y or k. You just plug it into the function, right? Just plug into the function. Now there are two types of, well, at least in this lecture, we only talk about open up or open downward parabola. We're not talking about sideways. That's different. There are two types of the parabolas. If the coefficient of x squared is positive, if a is positive, let me see what I highlighted in my note here. If a is positive, then your graph open upward. Smiley face, I call that. Okay. If vertex, so the vertex will be your minimum, right? Vertex will be the minimum. It's helpful when you do the application problem. You have a minimum and maximum. And the range will be from, you know the range, right? Range from k up to infinity. Where the graph starts, where it ends vertically. What if a is less than 0? Then the graph open downward, sad face. Vertex will be your maximum. Vertex will be your maximum, and then the range will be from -infinity up to k. when you graph a parabola, either upward or downward, there's certain thing I want you to show on the graph, which I will on the exam. First, you're gonna show me the axis of symmetry. It's a vertical line, so it's gonna be x equal. It always be x equal. I know it's tempted to do y equal because it looks like parallel to y axis, but it's actually x equal. Just remember that x equal. If I ask you what is the axis of symmetry, you say x equals something. Right? Don't just give me the number. That would be wrong. Right? I want the whole equation, so it's gonna be x equal. The domain, because it's the polynomial function, right? Quadratic is belong to the polynomial family. The domain will be all real number. To find the x-intercept, like I said, you're gonna set the y equals 0. So that's your y part. You set y equals 0 and then you solve for x. To find the y-intercept, you set x equals 0. So vice versa. So far, so good. By the way, today you tried only one problem. The question is in the question. The question is in the question, so I don't have to write out for you. Okay? When you open it, it's there. Any questions so far? Any questions so far? Those are just theory. Some properties of quadratic function. Given the general form, negative 2x squared plus 4x plus 3, I want you to write it in vertex form. Highlight in red. Find the maximum, minimum. Maximum, I highlighted in, I think I have in yellow. Minimum in green. No, maximum in yellow, right? Minimum in green. And the value of x that maximize or minimize the function. All right, that's later. But let's find the vertex form. Let's convert it into vertex form. So vertex form is like this. Y equal a times quantity of x minus h squared plus k. First, so I need to find a, I need to find h, I need to find k. Let's find h and k first, because we have a formula for those. Remember h equal what? Sometimes, yeah, thank you. Negative b over 2a. So equal negative, I would put the parenthesis around it. B will be 4, A will be negative 2. Negative 4 divided by negative 4, positive 1. And then to find K, you plug it in, right? Plug it in. So here is K of 1, actually, K of 1. So I have negative 2 something squared plus 4 times something plus 3. What do you have? So plus 1 there. Negative. Is it positive 5? Yeah. Equal 5. So K equal 5. Now, how do I find A? So that's X, or that's H, that's Y, okay. How do I find A? What is A? No, that's K. That's K. What is A? Actually, right in your face, actually. Next to right, ax squared plus bx plus c, right? A is -2. So plug it in. Finally, so final answer will be y equal -2 x minus 1 square plus 5. Hypothetically, if I have h is -1, just hypothetically, then it's not, instead of x minus 1, you're going to have x plus 1, right? Because x minus minus 1. So the minus is default. It's always there. It's always there. Maximum, minimum. Is it going to be a maximum or minimum? Minimum, right? Actually, it's open down. So it's going to be max. Right? It's -a, so your vertex is set face. So you have a maximum. You have a maximum. The value, so the value of x that maximize the function will be, what is the maximum value? That's your vertex, right? 1, 5. Yeah, 1. You're right, 1. So the value of x that maximize the function will be 1. Maximizes f of x is 1. Now I can change the question a little bit. I say find the maximum of the function, then you kind of say 1, 5, right? The whole thing, right? But if I just ask you for x, then just give me x. Number 2, use the quadratic below to answer part A through E. This is the set phase graph. Which point represent the vertex? Why don't you guys fill it out? You know, why don't you fill it out? I'll give you like 30 seconds to fill it out. I walk around, see how you do. Zoomer, please fill out number 2 on your own. If you want, you can put it in the chat as well. Yeah, very good, very fast. Very good. Still looking up, you said? Sorry. I think for that same reason, I think high school now they start at 9:20 or something instead of 8. Yeah. Like I don't know how you do it because you guys are younger than us. Like 8 o'clock is like 4 o'clock a.m. like to me.
4 p.m.
Yeah. Yeah. It's 8 a.m. and then you have to study math, chemistry. Which point represent the vertex? C, right? C. So you're gonna write letter C there. And then write an order pair that will be 1, 4. Most of people get that. Axis of symmetry. Very good. I'm glad you say x equal 1. On the exam, you just put that. Might be 0 because it don't make no sense. Right? Number 1, what 1? 1 is a coordinate or x equal 1. right? What is the maximum value of the function? 1, 4. 1, 4. That's your vertex. Find the range of the function from where to where? To 4. Should we put bracket at 4? Oops. No, I don't need to box it. Which point represent the x-intercept? Very good. So -1, 0. I want you to write the point out, order pairs, right? -1, 0, and 3, 0. How is the value of h related to x-intercept? How is 1 related to the intercept, x-intercept? Yeah, absolute value. Maybe I'm not. That's not I'm looking for. Yeah. Yeah, it's divide the graph into equal half, right? So so the distance between 1 to 3 is the same from -1 to 1, right? Maybe that's what you meant. Maybe that's what you meant. Okay, sure. Yeah. Yes. So your axis symmetry always the middle point of, I wouldn't say axis symmetry. The h point always the middle point of the x-intercepts. The point represent the y-intercept will be b, right? So that will be 0, 3. Very good. Let's move on. How to write equation of a quadratic function using vertex and the point of a graph. Okay, all right. So problem 3, they want you to eyeball the graph and come up with the equation. The vertex equation. You don't have to show the general equation, it's harder. So let me write this down first. Y equal a times x minus h all that square plus k. Do you know h and k? Yeah, right, you do. So you plug it in. Right? So y equal a times x minus 1, h is 1, square plus k is 4. How do I solve for a? Any suggestion? It's not like something I can eyeball. Maybe you can, but let's solve algebraically. Any suggestion how to solve for a? Huh? A is not the slope. Slope only apply for linear. It is quadratic. But thank you. Yeah, plug in a point, right? You can choose any point on the graph. Any point on the graph that will be the solution of the equation. Right? Any point. For me, my favorite is the intercepts because one of them is 0. It's just easy for computation. Maybe if we choose 0, 0, 3, you can choose -1, 0. Do you like? So 0, 3, you plug it in. Y is 3. X is 0. minus 1 square plus 4. 0 minus 1 is -1. -1 parentheses square is +1. So that's just a plus 4 equal 3. Subtract 4 both sides. So a equal -1. Your final answer will be y equal negative quantity of x minus 1 square plus 4. So first, yes, question. Y. Yes, you can use Y. Yeah. You got the same thing? She have the same thing. Oh, that's what you said. Sorry, I didn't really follow. Oh, okay, sorry. Sorry. Yeah, let's do for E because it's 1 for E, but it should be the same. Sorry about that. I just kind of do on my own term. So E is negative 4, -5. So Y is -5. X is 4 minus 1 squared plus 4. 4 minus 1 is 3, 3 squared 9, so 9a plus 4. Subtract 4, so 9a equal -9, a equal -1. Do you see? Oh, by the way, let me ask you a question before I move on. This formula right here, does it look familiar with you? What is it? Where do you see it? Or at least part of it? Huh? Yeah, quadratic, right? That's your quadratic formula. Right, so that's from the quadratic formula. Minus b plus minus square root of b squared minus 4ac over 2a. So if this part is 0, if this part is 0, then you have the vertex. H, you have H. Last part I highlight in black is called determinant. For this class, I'm not going to emphasize that, but determine how many solutions a quadratic function has. If you look at the function, the absolute value function that we did last time, and quadratic, there's similarity, right? There's similarity. HK are both vertex. I wouldn't call the vertex in absolute value because that's where it's very sharp. In calculus, there's no slope there, so it's not a considered vertex. But we're just gonna call it vertex here. It's kind of similar, right? We just one is sharper, the other is a little curvier. Let's graph this one. They give you values, so let's plot. They plot them in. -2, -8. That'll be here. -1, -3, right here. 0, 0, right here. 1, 1, 2, 0. And connect those dots. It's a quadratic curve, so please draw it. Don't draw it like a sharp T, like a absolute value function. Try to make it a little bit curved right there. Oops, sorry. Stop it right there first. Stop it right there. Write the vertex of part A, sketch the quadratic function. Part B, write the vertex form of the function. Why don't you guys do it? Why don't you guys do it? I want you to do it. By the way, if you want to complete this, you can look at this, right? This is symmetry right here. So 2 units away to 2 units to the left and another 2 units to the right, right? So it's another point right here. Keep going, keep going. Right, so from here to here, that's 3 units. So right there. Anyone got the equation yet? One, right, is your vertex. Plug it in, plug it in. So x minus 1 squared plus 1. Now you find A, you pick a point. I like my intercept, so I'm gonna pick 0, 0, even better, 0, 0. I'm gonna pick 0, 0. You can pick any of those you like. Y 0, x is 0. This is not 0. Careful, okay? You say A times 0, 0. No, it's not 0. You're gonna do the by order first. So inside first, 0 minus 1 is -1, -1 squared, 1. So A plus 1 equals 0, A equals -1. Is that the same one we did? I feel a little deja vu. Is that the same one? Up here? No? I don't know. No, it's not. It's not. It's negative +4. The other one's +4. But you guys okay with these problems? Grab a quadratic function. Here is more like your exam problem right here. I wrote the exam. I sent it to Tom and Nicole, waiting for them to give me feedback. Once they okay, I'll go ahead and write the other versions. I will tell you what to expect on the exam. I want you to do well in the class. Will H always be the x-intercept of the vertex? Yes, HK is your vertex, but I wouldn't call X and Y intercept. X, Y intercept means something that cross the X-axis or Y-axis, where HK does not cross, or at least most of the time they don't cross. But you're right, yeah, HK is always the vertex. Let's grab this one. Should I go through this? No, you'll be okay. You know all these. You know all those. You can read them. I want to get this function. So on the exam, same thing. I'll give you the function, and then I ask you a bunch of questions and you fill in, right? So what's the domain? What's the vertex? Axis symmetry, x-intercept, y-intercept, and then you graph. Supposed to be easy. Does the graph open up or down? Up, because yeah, A is 1, A is equal 1, so that's positive. Imply Open up. What do you say upward? Determine the vertex. We use the formula thing. So x equal negative b over 2a. You gotta remember on your own, it's not a given. B is negative 2. A is 1. 2 divided by 2, that's 1. Instead of x, I'll put x equal h equal that. My habit is just call x and y. They just call hk because of the vertex formula. And then y or k is, you plug it in, right? You plug it in. One square minus, so minus 3 minus 8, that's negative 10, negative 9. And then your vertex, you would write like this, v1 comma negative 9. And if I was you, I would box it because I need it later. Someone tell me the equation of the symmetry. Complete your answer. X equal 1, yeah. X equal 1. Yeah, I'm just gonna, the reason you see dash, because in reality they don't the graphing calculator or even decimal, they don't graph the axis symmetry for you. Just something I show you so that you see this symmetry. If you miss any point, you can always plot using other points. Determine the y-intercept. Like I said, you said what? Yeah, you said x equals 0. So when x 0, y is negative 8. Now we'll y 0 comma negative 8. For the y-intercept, you find the points. Find the point symmetry to the y-intercept. We'll come back to it. We'll come back to it once we graph it. I don't like question E, but we'll come back to it. It's to me it's just kind of redundant. Find the x-intercept. You said y equals 0, right? By the way, you don't always have x-intercept. Right? You don't. If your graph is stay above the x-axis or below the x-axis, they don't cross the x-axis. But you always cross the y-axis. Right? So graph open, just keep opening to infinity. Right? At some point you're gonna cross it, no matter where it is. But your x intercept can have it. So that means you set the whole function equals 0. I mean x squared minus 2x minus 8 equals 0. If you can factor it, don't use quadratic formula. It's like burning down the house just to roast a pig, right? But if you're not good at factoring, then yeah, go ahead and use quadratic formula. But let's factor this. What two numbers should I put there? -4 and +2. So that means x plus 2 equals 0. I mean x equals -2. Or x equals +4. So -2, 0, and 4, 0. 0, -8. 0, -8 right here. The point of symmetry, that will be the earth right here, right? Symmetry. So that would be 2 comma -8. All right, now your final thing, you graph them, and it should be consistent with your answer. If it's upward, it should be upward. Let's plot some point first. Vertex is 1, -9. Right here. I would label them as well. I don't want to lose silly point. And then the x-intercept is -2, 0, and then 4, 0. It should be your graph should making sense, right? If some point is off, like say your vertex is kind of right here, and then your y-intercept right here, doesn't make sense, right? You want to check your calculation again. So that's what I'm expecting on the exam. This problem is really similar to one of the exam problems. You're gonna fill them out, show me the work, right? Show me work. And then when you graph it, please label the axis symmetry and the vertex at least. Right? At least. Maybe label everything. Okay. It's fair. It's fair. Better than you'd rather this than the application problem. Let's do this one real quick. I'm gonna do real quick because it's very similar to 5. Open up, open down. Down, right? Because A negative. Determine the vertex. You use a formula x equal or k or h. Might have it. So x equal h equal -b over 2a. What is b? 0. Good, right? 2 times -2 doesn't matter. 0 divided by anything is 0. And then when you plug in 0 for function, was k? Also 0, right? Also 0. So 0, 0. That's your vertex. Determine the equation of the axis symmetry. Axis symmetry is x equal h. So h is 0, so x equals 0. It's just the y-axis. What is my y-intercept? When x0 is y0, and so 0, 0. Symmetry to the y-intercept, well, that's also the axis of symmetry. So symmetry is the point itself, right? So it's 0, 0. What is my x-intercept? There is just the same point, right? Same point, 0, 0. The origin is the both. So 0, 0 as well. Or you can plug it in, right? Y0 divide both side by 0. I'm sorry. Yeah, divide both side by -2. 0 divided by -2, x equals 0. Find other 2 point on the graph using axis symmetry to plot more. So this is not helpful, right? Information is not really helpful. There's a lot of zeros. So I gotta find some more point using the axis of symmetry. So let's see. If I plug in negative, now you cannot just plug any point. Say, Mimi, I want to plug, I'm gonna use this and then this, this. It's not true, right? You gotta use the equation because you don't know how y your graph gonna be, right? So you're gonna use your equation. If I choose x is -1, what's y equal? Yeah, very good. -2. Right? You plug it in. You plug it into that y equal -2x squared. So when x is -1, -1 squared is +1 times -2, still -2. Let's one more. How about x equal -2? X equal -2. -2 squared, that's 4. 4 times -2 is -8. So -1, -2, -2, -8. And then you can use the axis symmetry to plot the right side. Right? That, and that. And now you can graph. So I think the point here is that you whatever you got, right? This is whatever you got. Application. I'm going to try to. We're gonna do number 7. Let's see, number 7. Number. Do I do number 8? Maybe number 8. We'll see. Number 10. Definitely number 10 and number 11. Hopefully number 12 as well. All right, let's see. I gotta skip some because some are similar with others. Number 7. Your theory is here. You can read it yourself. I don't want to reread it for you. It's the same thing. A projectile is thrown upward with an initial velocity is 32 feet per second. After t second, its highest h above the ground is given by h of t, -16 t squared plus 32 t plus 48. It's a function of time, so it's t. When is the maximum height reached? Now, if you look at the quadratic, it's open down, right? So you're gonna have a maximum. I'm just gonna draw something like that. It's not the correct graph, but just something to work with. So my graph roughly looking like that. And my maximum will be right here. That'll be HK. In this case, what I'm gonna replace HK with T and capital H. Is that okay? That's what I can do. Y. What is the maximum height reach? In order to find the maximum height, I need to find T, right? Oh, when, I say when. So they're asking for T. When is the maximum height reached? When is the maximum height reached? So that means they ask for time. So time is T. So T equal H equal -B over 2A. B is 32. A is -16. 2 times -16, that's -32. So 1. What is my unit? No, this is when. So they're asking for seconds, right? 1 second. So after 1 second, it reaches the maximum height. What is the maximum height? So now they're asking, thank you, Amber. Now they're asking for capital H, right? They're asking for Y. For Y, that'll be your K. So capital H is the same thing as K. You plug it in. The answer is 64, and the unit will be feet. Right? Feet. Don't forget unit. So far, so good. That's what I meant by minimum and maximum can be very useful in application. It's allow you to find the maximum point of a projectile, a minimum cost of a business function. When does the object hit the ground? If it hit the ground, what's the height? 0, right? So if it hit the ground, mean H, capital H is 0. That means you set the equation equals 0 and then you solve. You solve for t. So negative 16 t squared plus 32t plus 48 equals 0. If I was you, I wouldn't be too eager to use quadratic formula. This is my least favorite quadratic formula. I'm going to divide everybody by negative 16. So I got t squared minus 2t minus 3 equals 0. Now you can factor. So that implies t equal negative 1 or t equal positive 3. Can time be negative? So that means you're going to eliminate that equation, that solution. So after 3 seconds, the ball hit the ground. What is the initial height of the object? Very good. How did you get that? Yeah, initial height means that's when you start, before you start throwing the ball, right? Just time is 0. So that means h of 0. And then you plug it in, 0 everywhere. I'm just going to show you work. You can just give me 48. We're just going to show you work just for the sake of the note. So 0, 0. So it's going to be 48 feet. So that's the initial height. Number 8 is similar. Please do it. Practice it on your own. Let's do number 9. Let's do number 9. Another so application. The first application number 1 is projectile. Right? So that's the first one. The second one is using the constraint. That's the second type of application for quadratic function. Using the constraint. So given a function and a constraint, here's your function. I'll highlight in red. It's my interest. That's my interest, right? My interest is a function. Constraint is not my interest, but it's more like I'm using it to find the whatever I need to. The constraint is that if I want to solve for y, if I want to find now, this is 2 variables. This function is 2 variables, right? You don't know how to find the vertex from that, right? You, at least not in this class. So I kind of convert it into 1 variable. How do I do that? Well, we're going to use the constraint. Right? So constraint tell me that x plus y is equal to 15. I'm going to solve for y. You can solve for x if you like, as long as you plug in. Maybe let's solve for y. Y will be x, 15 minus x. So step one, solve for y. So once you have y, you're gonna substitute it in the red function. So you want to substitute into q. So in here, q is a function of x, so I call it q of x equal x squared. Instead of y squared, we're gonna substitute with 15 minus x. So far, so good. And then you expand it out. So x squared plus, and this part right here, you're gonna write it into two binomials and then FOIL it. Erase that and do this first. So 15 minus x times 15 minus x. 15 times 15, that's 225. Minus 15x minus 15x plus x squared. So 225 minus 30x plus x squared. And then don't forget to bring down the x squared here. Simplify more. X squared plus x squared, that's 2x squared. Write it in descending order, so minus 30x first, and then add 225 last. So far, so good. So that's step one and step two. My goal, which is convert equation of two variables into just one variable. The reason being because I need to find the vertex. By the way, you're gonna have a maximum or minimum in this problem. So h equal negative b over 2a. Sometimes I call that x. B is negative 30. A is 2. So 15 half. K or y is going to be 2 times x squared minus 30 times x plus 225. Do you agree that this one cancel? Right. 30 divided by 2 is 15. 15 times 15 is 225. Well, rather than negative 225. It cancels with the positive 225. 2 squared is 4. 2 divided by 4 is 2. So 225 divided by 2. So find the answer. You can just calculate it. Why am I doing this? I'm doing this because I'm going to introduce to you application problem using constraint. Your job is to recognize which one is constraint, which one is a function. I think it's the hardest part. These are not bad, right? It's just computation. The only mistake that you make is probably arithmetic. But in real world, you're gonna know what is which. Right? The two numbers add up to 6. What is the smallest value of the sum of the first number and the twice the square of the second number? So to start out. I'm gonna let x, y be the two number. One point just to tell me that. X plus 6. I'm sorry. Two number add up to 6. So x plus y equals 6. What is the smallest value of the sum s? Of the first number. So the sum is the first number, which is x, plus twice the square of the second number. So 2y squared, right? Twice the square of the second. How do I know which one is constrained? I mean, without coloring, because I know it because I worked this one last night. For me, I would write out the two equation first, and then with the one that had larger degree, that will be your function of interest. Okay. And the linear one will be your constraint. Always true? No, it's not always true. But what's true is that the one with the higher degree will be your function of interest. Okay. Well, for this class, I don't think it's go any higher than quadratic. So linear will be your constraint, and then quadratic will be your function of interest. Can you substitute in? We're gonna substitute in for x. So x or y? Should I solve for x or should I solve for y? It's not wrong to solve for y, but I'll tell you why I want to solve for x. Once I have x, I'm gonna plug it in. So x, instead of just x, is gonna be 6 minus y plus 2y squared. Now, if you solve for y and you plug in for that y squared, you have to square it, right? And then you write out twice, you FOIL it. It takes longer times. So I choose to solve for x, but it's not wrong to solve for y. Let's write it in descending order. 2y squared minus y plus 6. So the vertex v is going to be negative b over 2a. You plug it in. B is -1. By the way, here xy is not important because it's application. It's application. It is a function of y. Right? A is 2, so 1/4. So it will be h, and then k will be 2 times 1/4 squared minus 1/4 plus 6. Can someone compute that for me? What you got? y, that will be your x, right? It will be your x. Flip around. All right, because I don't have my graphing calculator here, I'll fill it out for you. It's just not important, right? You got y and you got x. Number 11, let me finish this one. Farmer has 2,400 feet of fencing to fence the rectangular horse corral. So let me draw that for you. Yes. For 9. For 9. Oh, it's minimum because you open up. A is 2 mean you open up, right? It's positive, you open up. Yeah. When you open up, what's your bottom is in the bottom, right? Yeah, the round part. All right, I guess I don't have time. I don't want to hold you because you have another class. Yes. It's in the one. It's in the question inside. You see it. When you open it. You don't have to worry about 12 and 13. I know it's not going to be an exam, but try to do it.